This is a map of Paris. It might not look like a map because it's not a map you're supposed to see. It's a map that you feel with your hands. It's a centuries-old technology, a way of acquainting someone who's blind or visually impaired to a new environment. And it can be considered the first example of taking something that you see and turning it into something that you feel. If you think about the technologies that you interact with on a day-to-day basis, you're probably looking at a screen, whether that's your laptop, smartphone, or tablet. And as we rely on these devices to receive critical information, we face a very specific type of challenge. Every day, there are millions of people who perform important work that demands situational awareness. I'm thinking about the $242 million that's spent every year to compensate workers in heavy industry when they pull out their earplugs and try to talk to each other and suffer from hearing loss. I'm thinking about the 1.3 million active duty troops in the United States military who don't always have the luxury of considering the potential future consequences of not using hearing protection. At Somatic Labs, we think about communication and how much we rely on our eyes and ears, and we think we found a different way of solving this problem. We communicate information through touch. Our product is called the Zorb Platform. And on the left-hand side of this slide, you'll see one of our evaluation kits. It's a piece of electronics that can be embedded inside of any fabric or surface that comes in contact with your skin. We've put it inside of baseball caps, hard hats, a wristband, a belt. We've created a wide range of form factors to demonstrate the technology. And we've used it to communicate information. So if I wanted to draw your attention to something dangerous to your left, I could create a sensation that moves to the left across the surface of your forehead, drawing your eyes to what demands your attention or what needs your attention, and not removing your attention from the work you need to perform. But we don't just provide the hardware, we also provide a fully integrated software system that allows you to create sensations that communicate any form of meaning that's important to the task at hand. This is what that software looks like. It looks a little bit complicated from the screenshots, but we provide a tutorial that allows you to drag and drop different building blocks. And those lines you see on the bottom of the screen there, those represent the intensity of sensation at different points on the body. And the points of contact can also change. Whether our electronics need to be fit inside of a military helmet, a spacesuit, a wetsuit for diving underwater, or even just a bicycle helmet. You might be wondering why we're the right people to solve this problem. And the simplest answer to that question is that we work really hard at it. Just over the last 2 months alone, we've had over 20 multi-billion-dollar businesses reach out to us inquiring about our technology to learn more about how they can improve their products and workflows. We develop unique IP. We not only have a patent that's been granted, but a pipeline of provisional patents that we're working with our lawyer to turn into an IP portfolio. And most importantly, we listen to our customers. We spend time doing demonstrations of different form factors and designs to get a better understanding of how we deliver value with an integrated solution. And we develop everything in-house so that we can build the expertise that gives us a competitive edge. To give you an idea of where we came from, The company was founded in May of 2016, and we launched a pre-order campaign this September of the same year and raised $25,000, which was enough for us to get started. And we spent the following 9 months heads down just focusing on the engineering to make sure the technology was not only de-risked in terms of supply chain, manufacturing, and design, but also to get it to a point where we could show it to as many people as possible, to get an understanding of how it fit their needs. And from there, we delivered the first version of our hardware to our first users and started collecting more of their feedback. And now we're at a point where we've developed and designed the next version of our platform. And it fits into these 3 buckets. The first is industrial safety, where worker hearing loss prevention is a priority. And the second is military coordination, where the ability to send a silent and invisible message can quite literally be the difference between life and death. But if you think about any augmented reality technology that's out there, they're focusing on channels that are already overloaded. You have retina displays with immense detail. But when it comes to your sense of touch, the technology has not evolved since the Motorola StarTAC of 2 decades ago. As I mentioned before, I can create a sensation that moves across your skin. And we have a demonstration of this technology. So if you come up to us after the presentation, we'd be happy to show you how it works. And the ability to create that message through touch not only allows us the opportunity to give people critical information in real time, whether that's a value from a sensor, like a pressure gauge or a temperature reading, or maybe an instruction from a supervisor. But it also gives us the opportunity to allow people to focus their eyes and ears on their surroundings and the work that they need to perform. This is just a short sample of the companies that have contacted us with interest in integrating our technologies into the solutions that they provide. We're already working with one of the largest consumer electronics companies in the world. And we're looking at all of the inbound interest that we're receiving and working on selecting 1 or 2 more partners that can help us with our entry to market. Currently, we're raising a $500,000 seed round. And the focus of this fundraise is to work on evaluating the effectiveness of our technology in specific controlled circumstances. We want to collect the data that allows us to make a strong case that we're delivering value. We want to demonstrate exactly how many lives we're saving, exactly how easy it is to send a message through touch, exactly how much efficiency that you can gain by adding this additional channel of communication and reducing the amount of load on our eyes and ears. If you think about where this fits in with the status quo, the closest thing you have is a pager, which allows you to just send one signal. It's either on or off. We can send a wide range of signals, things that are directional, telling you to look in different directions, move in different directions. We can also send cues that are like an alarm, but not just one alarm. We can send multiple different types of alarms. We can communicate the value of a sensor, whether that's something like a heartbeat representing proximity, or the value of a pressure gauge that changes intensity of sensation according to the value that's being read off by that digital sensor. And as our environments become more sensor-rich, the value of our platform increases. We've brought on board a diverse group of advisors to help us grow. This includes a former product manager for Android at Google, or a medical doctor, a material scientist, a computational biologist, successful entrepreneurs. We're not afraid to ask for help. And I could tell you a little bit more about my team, but they're all here, and I would encourage you to introduce yourself to them. Actually, you guys should stand up. Say hi and ask them questions. One of the best things about working on this company is that I get to work with some of the smartest people I know. And if you introduce yourself to them, I think you'll come to the same conclusion. I pointed out a lot of use cases and ideas that exist on Earth, but one of the aspects of NASA iTech is thinking about how these technologies can go to space. And that's where I need your help. And we're especially curious about learning more about the types of conditions that you encounter where communication failures happen, where people are unable to get the information they need when they need it. We think that this is a technology that could be beneficial embedded inside of a spacesuit, or potentially in the facilities where satellites are manufactured, or even in underwater missions. But that's not my expertise, and that's where we're here to learn. We're working to reprogram the human sense of touch, and I'd be very happy if you join us. Thank you.
Great presentation. Really, I mean, I think this is one of the few cases where I can say you really have skin in the game. That's literally, right? I mean, so, and the beauty of startup that have hardware products is that you can actually try it. So I can't wait to be electrified by your device. And my question is, I mean, you answered a lot of questions already. Your presentation was very well done. What about security? Mm-hmm. You know, you mentioned a lot of very sensitive fields like the military. Mm-hmm. And I mean, if I'm a good hacker, you know, I could hack your system and provide a very confusing feeling to my platoon of US Marines, so they're going to go right rather than going left, mm-hmm. for example, right? So what's your strategy in having that shield of cybersecurity potentially to protect this product, or you rely on external platform? Mm-hmm. And yeah, that's basically my main question.
Yeah, so as part of our customer discovery process, we've spoken to folks in both the intelligence community as well as the Department of Energy who have told us a little bit about how they incorporate new technologies into their work. And one of the things that is especially clear is that they would be handling the communications layer. So we would not be using Bluetooth the way we do with our demos when it's connected to an iPhone. You know, they have a separate communication stack that's secure. And so we would hand off the security to, exactly. And we would simply be providing a display. And instead of the display being visual, it's a display that's through touch.
So Shantanu, I have a couple of quick questions. So one is, so do you envision with this new technology, just like with others in the past, that either you or others are going to develop like a new language of touch where there are going to be standards of what certain type of signals mean so that they can be used across the board, across multiple platforms?
Yeah, definitely. So to give you some context, I spent about 6 years working at a lab at Arizona State University, and one of the research questions that I was working on was seeing whether you already have associations already in your head with sensations that you feel on your skin. So one example would be, if I wanted to evoke a sensation of fear, I could send pulses up and down your spine. And that's a very visceral type of reaction that you can get. Those are the types of questions that we answer as we have more users, because the more users we have, we're able to test out different variations of the types of sensations we create, and we can ask people questions. And that's something that we do on a regular basis. We even created an internal tool that we just use to get a better understanding of what language is most intuitive and easy to understand for our users. And we're using that recognition rate and the ability to distinguish between different sensations as the metric that we're trying to optimize.
Thanks. And then the other quick question is, you mentioned something about using this technology to save lives or at least quantify how you're saving lives. Can you expand a little bit on that, how you're going to do that?
Yeah, so we can start with very simple, straightforward use cases that don't involve saving lives at all. So one example is that right now we're working with a soccer coach, and all we're doing is seeing how easily he's able to communicate instructions to the players on the field. So it's just a matter of whether the players are in the right position. How quickly are they able to respond to a different instruction that he gives them. And that's an easy way for us to collect a proxy for the underlying metric, which is how quickly is an instruction being relayed, how easily is the person able to understand it. And once we've tested the use cases out in these very low-risk environments, we can then move and transition over to those high-risk environments. And we're looking for those pilot test opportunities right now because we've already done some of the basic testing of the electronics to make sure that it works. And we're looking for opportunities to create more of those controlled trials.
Is about the signals being sent to, so you talked about the product and the many use cases on point of contact, so being in a helmet, being on the surface of the skin. I would like you to expand about where those signals are coming from and how they're controlled. I imagine there's a variation of automation versus human in the loop. So if you could just give more information on how those signals are given. Yeah,
definitely. So right now, everything is a human in the loop in terms of the way we are testing things out. So we have an iPhone where a person has a menu of options of different types of signals that they can send. And the demonstration that we have here today is a very straightforward one of being able to send different directional cues, left, right, forward, backward, and a couple different alarms. But there's, we allow people to create their own meaning, using our software. So, if there is a specific set of commands or a specific set of instructions that are important to you, we would work with you to figure out what those are, and then we can show you our software to help you tweak and customize it however you want. And in terms of the automation side, it's also scriptable. So if you want to integrate with software, that's something that does have some integration cost associated with it. Like you would have to, have a sensor that's you're able to, fetch the data from, and you'd have to come up with some type of transformation of that data. But we also have some tools that allow you to do that.
I'm curious about the interface to the human, the actual end effector or transducer or whatever that is. And what is that technology, and what is the signal, or what is the pulse or sensation that the human is feeling, or it's being given to them? I'm not following that.
Yeah, definitely. So right now we actually just make use of multiple actuators which are commodity hardware. So it's a linear resonant actuator. It's slightly better than what you find in a lot of cell phones or video game controllers. It vibrates at 205 hertz and targets a specific receptor, the lamellar corpuscles, underneath your skin. But we also have in development another set of technologies that allow us to change which receptors we're targeting based on changing the frequency. And so right now we allow you to control the amplitude, and we are working towards being able to control frequency and amplitude. And we're also working on integrating the ability to use multiple different types of actuators. So for example, a piezoelectric actuator can work in microgravity, can work underwater, and that's what we see as the next step of the platform, since the supply chain and the availability of that particular type of component is slowly starting to improve.
I'm really excited about this. Am I good? There I am. Okay. I'd like to give you a chance to comment on a place where I think this could be brought into use like right away. Right now, I work in test and development of avionics, and the DoD has developed a system that can detect incoming fire, bullets, or rockets to helicopters, because the helicopters are so loud. The vibration is so high that the pilots can't tell when they've come under fire. And so the system is already developed, installed, and deployed to detect the direction that the incoming fire, where it's coming from, based on sorting out, seeing the shockwave or Doppler shifts. But where they struggle with is how to present that information to the pilots. You see where I'm going with this? They initially just put an extra little display that would tell them, oh, it's coming from this sector, it's coming from over here. And the pilot said, I'm in the middle of a very high demand task. There's no way I'm going to divert my attention to go look at this screen in order to see. Just happen to glance over there on the off chance that I might have been being shot at that moment. Can you comment to where you could see? I see this being a potential way that you provide that information in a way that does not distract them from the key task of doing operating aircraft.
Yeah, definitely. So the first question that we ask is, how do we make sure that a user doesn't have to learn a new behavior? So the thing that we would ask is, okay, what are the pilots already wearing? Are they already wearing helmets? Are they already wearing a headband? Or what is the stuff that's already on their body as a requirement for the job? And then we'd look at the points of contact that we'd make, within what they're already using and what's already on them, and we'd see how we can embed the electronics into that surface. And then from there, you could prototype really quickly. I'm talking in a matter of a few hours. Design multiple different types of signals that you can test with the pilots. See, okay, whether the intensity needs to be really high, whether the sensitivity is good enough while they're flying the plane that you don't have to have a really high intensity sensation. Those are all the types of parameters that we would tweak according to the feedback that we get.
I see this as such an incredibly rich area. I can't wait to talk to you more and try some of this out. But let me ask some of the downsides of the technology. Have you looked at that? Is there interference with the natural nervous system reflexes in people, and how could this have negative effects? Have you looked at that to analyze that side of the coin?
Yeah, definitely. So since you are also, it's not like you're completely removing the cognitive load of having that information being presented to you. So there is, at least a little bit of distraction, you could say, or a little bit of attention that's paid to something that you feel on your skin versus something that you're looking at. So that's something that has been studied, and I'd have to, pull up some of the papers to look back at that in more detail. But as far as the negative effects, we imagine this as something that we're not using hardware or electronics that are significantly different from a lot of the sensations that are created by existing technologies. We're just increasing the resolution. So the type of feeling that you're getting is just more detailed than what you get off of your phone, but it's not doing anything different to your skin. It's just providing that same kind of, I guess you could say, a linear force that's going into your skin. And that's something that is, we use cell phones and video game controllers really widely now, and there hasn't been any significant drawback.
There's not much deep penetration at this point?
Oh, no. So it doesn't link in directly to your nervous system or have anything that's inside or underneath your skin. Because it's just on the surface of your skin, and we're simply increasing the detail and resolution of the sensation that we could provide. There's not anything that's more dangerous or more difficult in terms of the end user experience and the type of impact it would have on the user.
Is there much of a variation in response to the signals? So for instance, my cell phone vibrates. If I'm busy, I'm 99% of the time I'm not going to notice it. I just wondered what the variation of this and how sensitive or how much variation you put on it to get people's attention.
Yeah, so one of the things that we take advantage of is actually kind of I guess you could say, a gap in your brain's perceptual system. So similar to how you experience optical illusions when you look at a page that's has an image that's printed on it, but it seems like it's moving, we accomplish the same thing with your skin. Again, we're only creating sensations that are on the surface of your skin, but we could trick your brain into feeling like there's something moving across your skin, when in reality, that sensation is actually just a static sensation at a couple different points. And so that's a type of thing that we really just came across with trial and error, just trying a lot of different variations and seeing what worked. But that's one way of making the sensation more interesting and engaging, but also adding a level of information associated with that. So depending on how fast the sensation is moving, that can signify how important or how quickly you need to respond, or the intensity of the sensation can be used to communicate the urgency of a message. Those are the types of design patterns that we're constantly evaluating and trying to figure out what works best.
So I love the idea of the situational awareness that we were talking about before, because that's an obvious low-hanging fruit. What I did consider about this is that it could become a full-up communication system. I mean, I don't want to go and say Morse code, but I mean, I'll say Morse code. I mean, it really could be a very silent and effective system of communication that's nobody else is aware of in a situation like, for example, between a sky marshal and a pilot of a civil airline. Have you thought about those kind of issues?
One of the observations that we had, especially when we were talking to and doing demonstrations to potential customers, was we noticed a recurring pattern that anywhere where someone is using hand signals to communicate, we see a potential communication failure when you don't have line of sight. So if you're trying to signal someone with your hands, they have to be looking at you to receive the message. And oftentimes you're either too far away to really see with enough detail, or it's in an environment where you don't necessarily want everyone to know, what you're trying to signal. And in any of those situations, it's always better to send something that's silent and invisible, and only the intended recipient can receive that message.
So just one comment. It seems like from the comments with Ramona and with Mickey that you've explored essentially different ways to employ pressure. Have you figured out ways to employ either hot and cold or pleasure and pain to sort of create a richer palette for those things?
Yeah, so the one constraint with that is actually power consumption. So the electronics do exist for changing hot and cold. It's just that if you want to power it with a standard battery, or if you want something that's really compact with kind of a compact enclosure, hot and cold just consumes way too much power to actually be viable for any wearable application. So you'd end up either needing to plug into a power outlet or have a lithium-ion battery pack that's pretty bulky in size. Thanks.